Hello, my name is Simon Hawkins of Metcal. Today I'm going to show you some very basic surface mount rework techniques using the Metcal MX500 system. The system comprises of a soldering iron, which can convert into a fixed head surface mount removal tool, and also the Talon tool, which is a tweezer type tool for removing discrete components and SOIC or dual inline packages. I also have a variety of other pieces of equipment around me which I'd like to speak you through. Basically, I have a series of tip cartridges which fit into these tools for removing the specific components. We have here what we call a slot tip for removing discrete components, capacitors and resistors. We have a tunnel tip for removing SOICs and dual inline packages, and two types of quad tool for removing QFPs and PLCCs. I also have a blade tip for cleaning up a circuit board after removing the component, and a hoof tip or multi-lead soldering tip for replacing components. I also have a variety of blade tips here for fitting into the Talon tool for, as I said, removing dual inline packages. Other pieces of equipment that are required for the removal process are solder wire, flux, solder braid, and some cutters. Also, if required, you may need some cleaning solutions and some lint-free cloth for cleaning off flux residues. Before I actually show you the rework process, I would like to talk a little bit about surface mount technology and smart heat technology and the benefits that smart heat gives in this type of rework process. Metcal soldering irons work in totally the opposite way to all other conventional soldering irons and rework systems. Metcal soldering systems change their power output automatically to keep the tip temperature constant. This allows us to put in a repeatable, precise amount of thermal energy to each solder joint, meaning that we are not producing any thermal damage to components or circuit boards during the soldering operation. This is known as direct power heating or smart heat. All other soldering irons require you to manually change the temperature to change the amount of energy you are using. These are called stored energy systems and require the operator to change the parameters for each solder joint. Smart heat actually gives you total process control in the amount of thermal energy you require. Attached to this soldering system, I actually have a power meter, and by observing the power meter we can actually see the smart heat phenomenon occurring. When I switch the system on, the resistance and magnetic permeability in the heater is very high, and we see a high power output. As the tip reaches temperature, there is a change of the magnetic permeability, a change in resistance, and the power output drops. The system has now reached temperature. Systems reach temperature very quickly, typically within 10 seconds. As I actually place a thermal load or thermal demand onto the soldering iron, the power output changes automatically to keep the tip temperature constant. If I'm soldering a very large thermal load, I get a very high power output. If I'm soldering something very small, I get a very small power output. So the power output changes automatically to keep the tip temperature constant. The main advantage of soldering in this particular way is that we can solder very heavy loads and very light loads without having to change any settings on the equipment. And to actually show you this phenomenon occurring, again, I have here a high thermal load and a very fine thermal load. So I take my soldering iron and I will start to feed in the solder onto the heavy load. As I start to do this, you should see the power on the power meter rise up to keep the tip temperature constant. And this allows me to feed the solder in freely without the tip temperature dropping. If I tried to do this with a stored energy iron, the tip temperature would drop because the power output is always constant. But with the Metcal system, the power output has changed to keep the tip temperature constant. And if you observe the solder on the coin, you can see now that the solder is melting. As soon as I remove the tip from the coin, you should see the power on the power meter has dropped. And as soon as I put the tip back on, the power meter rises. I can move from doing very heavy soldering to doing very light soldering without worrying about causing thermal damage. Metcal Smart Heat technology allows for this change from heavy duty to light duty without causing any thermal damage. And that is effectively what Smart Heat is. Smart Heat gives you total process control. This is what a Metcal tip cartridge looks like. The system is unique in that the tip and the heater are all contained in one small system. The system consists of a laminate heater and a series of wires that induce a high-frequency current into this heater, producing the skin effect that gives us this change in power output. The important thing is that the system is self-regulating. It is the heater itself that determines how much thermal energy is required. There is no independent control loop, no thermostats, and no switching. Because we are using a high frequency, the heater is very, very small, and we are able to locate it very, very close to the tip itself. This means that it reacts very, very quickly to any thermal demands that are required of it. With the Metcal tip cartridge, you get everything. It is a complete system in itself. You have the heating, you have the thermal control, you have no maintenance because everything is contained within the tip cartridge. Also, there is no requirement for calibration. It is a complete, light, ergonomic system. Now I'm going to show you some rework techniques using the Metcal MX system. First of all, I'm going to show you some very simple techniques for removing some discrete chip resistors. This is a Metcal slot tip, and it is this type of tip we use for removing passive chip components. These components are very small, and therefore a high tip temperature is not needed. We would only rework these using a tip temperature typically around 270 degrees centigrade. Before removing a component, we need to place some solder inside the tip to help with thermal transfer. So I have placed some solder inside the tip cartridge. I then move over to the circuit board. I then place the tip cartridge over the component, wait for reflow, and remove. Before replacing a component, the first thing you need to do is to take the excess solder off the pads, and this can be achieved with some solder braid and a standard Metcal tip cartridge. Having picked the component up, the first thing to do is to apply or reapply some fresh solder onto one of the pads. We can then flux the pad, pick the component up with some tweezers, place the component carefully in position over the solder, reflow that solder, await for the solder to melt and wet the component. Allow the solder to cool down and remove the tweezers. Again, you can reflow or resolder the remaining side in the conventional way. So now I'm going to show the removal method for an SOIC or dual inline package. Again, the type of tip cartridge we use is the Metcal tunnel tip. Before reworking, we apply some solder inside the tip, which will help transfer the heat from the tip to the component. Once the solder has been applied, we move over to the circuit board and we place the tip onto the component, making sure that we are touching all the pads. Again, it's important not to apply any great pressure here, and when reflow has occurred, we remove the component. The next part of the process is to take the excess solder off the pads. You place the braid over the pads and you bring the Metcal blade tip over this and contact the pads to remove the solder. And then you swipe the braid once over the pads to remove the solder. Again, repeat this for the other side. The next thing to do is, once you have removed the excess solder from the pads, is to clean the circuit board to remove any flux residues. This will make the resoldering of the component easier. So I have removed the flux residues and I'm drying the board with some lint-free cloth. So again, the board is left very, very clean. Having cleaned the area to enable me to put the component on successfully, I'm just going to apply a very small amount of solder onto the first pad here, like so. I then bring in the component I want to replace, place it onto the pad, and reflow the solder again to anchor the component into position, like so. I then place some rework flux on the legs of the component. I then take this type of soldering iron tip, known as the hoof tip or the multi-lead soldering tip. I then apply some solder onto this face of the tip, like so. And I then move the tip down the legs of the component, soldering each lead as I go. Again, the process is repeated for the other side. The component is fluxed. Solder is placed onto the tip surface like so. A little bit extra. And then the tip is moved from joint to joint, soldering each leg as you move down the component. The component is now cleaned to remove any flux residues and dried using some lint-free cloth. And the rework process is complete. The next rework process I'm going to show is the removal of a QFP. Before we actually remove this type of component, we have to prepare the component for removal. The first thing we do is we place some solder wire around the component to act as a preform. This preform will melt when I place the tip cartridge onto the component, and the melting of the solder will transfer the thermal energy more efficiently from the tip to the pads. Again, to promote efficient thermal transfer, I will also apply some flux onto the component to make the rework process a little quicker. Again, I will apply some solder inside the tip cartridge, like so. I then bring the tip cartridge down on top of the component, again making sure that I'm touching all the legs. Again, it is important that no pressure is applied here. Just rest the tip cartridge onto the component and await reflow. Once the component has reflowed, then you remove the component from the circuit board. As with the SOIC component, the next part of the process is to remove the excess solder from the pads. And again, this is done using solder braid and the Metcal blade tip. Ready? After removing the excess solder, the pad area is again cleaned up to remove any flux residues that may be present. This will make replacing the component very much easier. Again, the replacement method is the same. The first thing to do is to place a small amount of solder onto the tip and apply a little bit onto the first pad. The component is then brought into position and anchored into position like so. Once you have anchored the component in two positions, we can then reflow, or we can then resolder in the same way as we did before. We apply a small amount of solder onto the tip. Again, for this type of component, only a very small amount of solder is actually needed. We then flux the component legs like so, and we then use exactly the same technique to solder the component in position. We then repeat the process for the other sides. The removal process for the PLCC devices is very, very similar to that with the QFPs. Again, we have to prepare the component by applying a solder preform around the component to help with thermal transfer. Once the solder has been wrapped around the component, we tin the inside of the tip cartridge. Like so. And again, we place the tip onto the component and wait for rework or reflow. Once the component has reflowed, we remove it. The removal of the solder away from the pads is again the same process we have used for the QFPs and the SOICs. Again, we clean the area after removing the solder to remove any flux residues that may be present. Again, prior to placing the component in position, just place a little bit of solder onto the corner pads like so. Then we need to place the component in position and then reflow that solder to anchor the component in the correct position. Again, to replace a PLCC, we use the same tip we have been using for all the components so far. This is, as I said, the hoof tip, or the multi-lead soldering tip, but we use it in slightly a different way. We apply some solder on the bottom surface, and also a little bit of solder on the top surface. So we are in fact applying solder in two positions. We then flux the component as we did before, and again we move the tip from joint to joint, soldering each one as we move down. If you have a PLCC device that is very closely packed to adjacent components, you can still use the drag soldering technique, but you can use a different tip called the knife tip. But the general principle of use is the same. We tin one side like so. We then flux the component like so, and then we can very easily solder the legs as we move down, like so. I've shown you some rework techniques using the soldering iron and using the what I call the fixed head tip cartridges. There is an alternative method for rework using the tweezer tool. And the advantage that the tweezer tool has over the fixed head method is that you can adjust the distance between the tips, which means that one set of tips can actually rework a variety of different types of components. So the system is a little bit more flexible. The performance of the tips is identical to the fixed head method. They still use the smart heat technology. The basic rework technique is very, very simple. Basically, it involves tinning the tips, placing the tips on each side of the component, and then removing that component. Replacement of the component is done in the same way that we have shown you already. So once you have tinned the tips, you then bring them down onto the pads, you reflow the solder, and you remove the component. Dual inline packages like these can also be reworked using the tweezer tool, using different length blade tips. But the principle is the same. You tin the tips, and then you bring the tips down around the component. You then touch the legs and wait for reflow. And once reflow has occurred, you remove the component. The important thing about surface mount rework is that you need to control the amount of thermal energy that you use to remove and replace components. I hope today that I've shown you that surface mount rework is very, very simple, and once you have the basic techniques, then it is possible to rework quite complex components using fairly simple equipment. But the important thing is, if you are to use simple equipment, that equipment must give you process control. Smart Heat gives you that process control and allows you to utilize a very simple techniques for surface mount rework. Thank you very much. We have spoken primarily today about surface mount rework, but an additional attachment that can be used with the MX system is a desolder gun, which can be used for reworking through-hole components. The gun works on a Venturi system. Compressed air is fed into the gun here, and a Venturi cartridge based in the handle here converts that compression into a vacuum. The vacuum is applied inside this chamber here and allows solder to be sucked through the tip and into a collection chamber, which is located inside the gun here. The working principle, again, of the rework cartridge here is the same as the other cartridges I've shown you today. It is using the Smart Heat principle. Removing through-hole components is very, very straightforward. Again, as we did with surface mount rework, we need to tin the tip to promote thermal transfer. We then place the tip over the lead we want to rework, await for reflow, and apply the vacuum. We then move to the other lead on the component. Again, we wait for reflow, and then apply the vacuum. After we have removed the solder, we just need to check that we have desoldered the legs successfully before we actually remove the component from the circuit board. And we can see that this leg is now loose, and so is this leg here. So we are now ready to remove the component. Once you have ensured that all the solder has been removed and the legs are free, then it is possible to remove the component. Again, do this carefully so you don't cause any damage to the circuit board. One of the important things about using surface mount rework equipment is its flexibility. And the advantage the Metcal system has is the ability to change from one job function to another very, very quickly. And this is achieved by the very, very quick tip changeover It's very, very easy to change tips using the Metcal system. You just remove the tip cartridges very simply, like so. And you can put the new tip in very, very simply, like that. This means that you can change from one job function to another very, very quickly. And the rapid heat-up time of the tip cartridges mean that you maintain your productivity. Thank you very much for watching this video. I hope that I've demonstrated to you that rework, both surface mount and through-hole, is a relatively straightforward business. If you would like to borrow some Metcal equipment, then please contact your local distributor and he will come in and show you how to use this equipment. But anyway, thank you for watching and good luck with your rework. Thank you.